Right, let's start our discussion on the test. Question 1. You were given the amount of energy, mass, temperature, initial, and the specific heat capacity. So let's put it in our formula, mc delta T. But before input the data, please make sure that this time we are using kilogram. So you should change it into gram, like this. After solving the equation, you will know that the answer will be D. Question 2. This is a question about mixing. So you have a cold alcohol mixed with a warm water. So the energy gained by the cold alcohol will equals to the energy lost by the warm water. So let's see. This one is the energy gained by the cold alcohol. This is the energy lost by the warm water. Now, make sure you place the temperature change in the correct order such that both of them are positive value on the left hand side and on the right hand side. Again, after solving the equation, you can see the specific heat capacity for the alcohol is 1.72, which is boil. Next one. First, we name two equations as 1 and 2. And you can see equation 2 is actually the backward or the reverse version of equation 1. Since the equation 1 we got negative value in delta H, so for the equation 2, the value for enthalpy change must be positive, right? So choice C and D won't be the answer. Next, we study the amount of CO2 involved. In equation 1, only 3 of them are involved, but in equation 2, 6 CO2 is involved. So we can conclude that the value should times 2 because you double the amount of equation. So the answer will be A. For equation 4, before everything, please write down this formula. The temperature rise should equals to the amount of reaction, or in neutralization is the amount of water formed over the volume. So with this idea, let's study W and X. For W, the amount of water formed is this one over the total volume, okay, in dm cube. What about the case of X? With X, the amount of water formed is double, well, but at the same time, the total volume is also double to 100 cm cube. So you can see they are actually equal. So we got the idea. W equals to X. With this idea, we can get the answer already, but we are not happy with that. So what about Y and Z? And you can see the same situation happened again, right? Y equals to Z. But if you study W and Y, and you can see Y actually with the same total volume, but since Y doubled the amount of water formed, so Y should equals to 2W, right? Take it easy this time. We only need to compare the strength, so the answer D still holds. Question 5. Yes, there is a typo here, right? In statement 3, but this will not affect our final answer. So first of all, if you study the enthalpy level diagram, and you will see the reactant and the product, because this is a exothermic reaction, they should look like this. So of course, P, the product, is in lower position, which is more stable energetically. So statement 1 is correct. Statement 2, is it fulfill the enthalpy change of formation of iron 3 oxide? Well, yes, if you study the definition. What about 3? If the forward reaction formation of iron 3 oxide is exothermic, well, that means decompose of iron 3 oxide back to element should be endothermic, right? This is no point for the energy release. So even without the typo, statement 3 still incorrect, and our answer will be A. Next one is the structural question. First, you are requested to write down the standard enthalpy change of combustion of ammonia. 1 mole of chemical is combust completely in standard condition. So here shows. Don't forget to write down the corresponding physical state. And the second mass will be given for the label. Now, here shows. If 4 ammonia is involved, then the enthalpy change will be 900 and something. And now we only have 1 mole of ammonia involved. So the value will be divided by 4, like this. The second one, what about 30 grams of ammonia is involved? So first, let's find the number of mole. Yes, I know the molar mass for ammonia is 17 grams per mole. And the heat release will be, now if you study, 1 mole will be 200 something. Now it's 1.76. That will be, some of you may notice that, well, why the negative sign is disappear? Because I was asked how much heat is released, which is included already. This is the first point. The second point will be the unit, because we have considered 1.76 mole, so the unit will be kilojoule only. Next is the combustion. So first, definition of combustion, so please refer to your notes. I won't repeat here. The next one is enthalpy change of combustion. Well, combustion, that means is per mole. So first, with MC delta T, let's find the energy given out in our experiment. This amount of energy is given out. Next is the number of mole of butyl 1 used is the subtraction of mass over the molar mass again. So the enthalpy change of combustion will be something like this. So first, you can see with the enthalpy change of combustion, the negative sign is here. The second one, because the question requests kilojoule per mole as the final unit, so I need to divide values by 1000. Next is the chemical equation with the state symbol. Well, this is easy. No tricky at all. Finally, but this is important, many of you get the incorrect answer. Besides heat loss, one more reason why the final example or the final value is different from the theoretical one is, okay, many of you just mentioned, because the specific heat capacity of the calorimeter is negated. Oh, yes, this is true, but not accepted because you are given already. So please give me more reason for that. So here I suggest 2. The first one is typical, is incomplete combustion of butyl 1 node. The second one, the experiment is not performed in the standard condition. That's it. Yes, some of you suggest that, so can I mention the some heat energy is absorbed by the thermometer, but not the calorimeter? Well, this is not accepted because the calorimeter included the thermometer. So you should give another reason for that. Well, question 3. So with such kind of reaction, you should include 3 lines in your diagram. Oh, sorry for the poor hand drawing because I don't have any equipment here. Now, here should be the highest temperature. It should be 39 degrees Celsius. And yes, with the calculation, the temperature change or temperature rise is 15 degrees Celsius. The next one, alright, some of you feel confused. Calculate the enthalpy change during this experiment. I haven't mentioned enthalpy change of what, so feel free. The final value will be kilojoule as unit, and the calculation is simple. mc delta T, like this. Next one, alright, the definition, please refer to your notes. And what about the thermochemical equation this time? Sulfurous acid is to be AQ. But for the sodium hydroxide, you are feel free to mention solid or AQ, because it depends on you accept it will react before dissolving or after dissolving. Both of them are correct, don't worry. Like this, thermochemical equation for the enthalpy change of neutralization. So, according to the definition, the water's coefficients must be equals to 1. Next, why there are difference between two acids? You should mention H2SO3 is a weak acid, or never try to miss the keyword. Weak acid this time is the keyword. So many of you just mentioned sulfuric acid is strong but not for H2SO3. This answer is no good, because what is meant by but not, right? So please mention it's a weak acid. Yes, this statement is typical, right? The first mark is here, the second mark will be here. Part of energy will be consumed in the ionization and make the result less exothermic. Ionization is the key word. Finally, well, this is very difficult. Many of you cannot get marks from that. Calculate the concentration of the H2SO3. Now, first of all, with the energy given out in the experiment and with the value given here, minus 48.7 kilojoule per mole. Let's see. So if you study the definition, now, if produce 1 mole of water, you give you 48.7 kilojoule, then our equation can be held to find the amount of water given out in the whole process or whole reaction. Now, because H2SO3 is dibasic, so the amount of H2SO3 should be half to that of water formed, right? 0.016. And finally, the final concentration will be the number of mole over volume. That's it. Yeah, if you feel confused in calculating this kind of questions, please refer to the definition. First of all, find out amount of water formed or given out. Then use the traditional mole calculation in acid. 1 dibasic acid will give you 2 moles of water, and you can find the number of mole of acid. Okay, so this is the end of this chapter test.